Hello everyone, welcome back to our channel Problematical. Let's discuss exercise 2.3 from second chapter Relations and Functions, class 11th Maths ncert. The first question is, which of the following relations are functions? Give reasons. If it is a function, determine its domain and range. Now, a relation is a function only if one particular element has one particular domain has a unique range, or one particular value has a unique image. In the first part, your domain and ranges are to be defined only if it is a function. So, in the first part, 2, 5, 8, 11, 14, 17 are unique values, are different elements, and these different elements have their respective unique images. So, since 2, 5, 8, 11, 14, and 17 are elements of domain of the given relation, and they have unique images Therefore, the relation is a function. Okay. If a relation is a function, the domain of the relation will be equal to domain of function, and the range of relation will be equal to range of function. So domain of function f, let's just write a domain, but understand that it is the domain of function. It will be equal to set of the first values of your ordered pair, 2, 5, 8, 11, 14, and 17. And your range will be equal to your images, which is just 1. Let's consider the third example first. 1, 3, 1, 5, 2, 5. Here, 1, the domain value 1 has 2 different images. That means since domain 1 corresponds to 2 images, that is 3 and 5. That means when you place the value of x as 1 in your equation, your y value is either 3 or 5. At different scenarios, you're getting different values, which is unexpected. Therefore, the relation, it will be a relation, but never a function. The relation is not a function. Here also, your domain will be there, but this domain is just for the relation. No domain is present for a function because it's not a function. Second question. Here, your domain are unique. 2, 4, 6, 8, 10, 12, 14, they are unique in nature. So, since domains of relation, that is 2, 4, 6, 8, 10, and 12, and 14 have unique images, therefore, relation or given relation is a function. Then you can mention this is your domain and your range would be The second value is 1, 2, 3, 4, 5, 6, 7. This is your domain of your function, and your range will be 1, 2, 3, 4, 5, 6, and 7. Find the domain and range of the following real functions. Nothing else is asked here. So find the domain and range of the following real functions. So real functions are given to you. F of x is given to you as minus mod of x. Now whenever mod of x is mentioned, there's a specific way how you can represent it. We know that mod of x can be written as the value of mod of x is x, then x is greater than 0. It is same x when x is equals to 0, and it is minus x when x is less than 0. So the first two values can be summarized as it is x when x is greater than equals to 0, and it is minus x when x is less than 0. Now what happens over here? Therefore f of x can be written as minus of mod x diy. When you place a minus sign over here, these signs will be inverted. These signs will be inverted. So f of x is equals to minus of mod x, which can be written as minus x for x greater than equals to 0, and its value is plus x for x less than 0. Here, f of x is defined for all x belongs to R, for all real values. If you place any real value, x is on the number line. That means x is greater than 0 over here, x is less than 0 over here. For any x which is real value, if x belongs to real value, then what is the domain of f? What is the range of f? For all real values, you will get values which are, let's draw it on the number line and understand it. When you place the value of x as over here, positive, 0 or greater than 0, when your x value is positive, 0 or greater than 0, your x value, mod of x will always give you a positive value. Negative of that will give you a negative value. So for x is positive, if x is positive, say x is equals to 1, so your f of x will be equal to minus of this value. X is positive, so it should be a minus of this value. Minus x, not 1. If x is negative, minus 2, then f of x is as it is. F of minus 2 will be equals to minus 2 itself. So for positive value, you're getting a negative value. For a negative value, you're getting a positive value. For all these values, your value is minus of x. That means for each of these values, you'll get a negative value. For 0, you'll get a 0, but for each of these values, you'll get a negative value. That means you will get a 0. For each of these values, you're getting x itself. All these are negative by default, so you're always getting a negative value, or you're getting a 0. So your f of x will give you positive, will give you a negative value, and if you place a negative over here, you'll still get a negative value. So you're always getting a negative value in your range, but your domain can be anything. So domain of f of x can be anything. Let's say anything means it belongs to R, a real value. Range of f of x can be, here the range would be 0 or anything left of that, because ultimately what you're getting is a negative value. On the number line, this negative value is based on the left hand side. So you're getting anything from minus infinity to 0, including the value of 0, and here you'll place round bracket since it is minus infinity. Next, in your second value, your f of x is equals to root of 9 minus x square. Now, what does this mean? It means that you can place any value of x. It is x square. So whatever value of x you place, you will always get a positive value over here. But your root over here should have a positive value. As of now, the concept of imaginary terms and complex numbers are not introduced to you. You'll encounter that in your 5th chapter of this book. But we need the root value to be a positive value. You have to find the domain and range of the following real functions, given that the functions are real. So ultimately, f of x value should be a real value. If you consider values on the number line, what happens when you place the x value as 0? If x is equal to 0, f of x is positive. When will f of x be negative? F of x will be negative when root of 9 minus x square will be equal to root of negative value. That means if you have when will f of x be not equal to a real value? It will not be a real value when there is a negative value of the root, which means 9 minus x square is negative. Now, this difference is negative when 9 is less than x square or x square is greater than 9. For x is equals to 0, let's check for this condition. For x square is equals to 0, 9 is less than 0 square, which is true. X is equals to 1, 9 is less than 1 square, which is 1, which is true condition. X is equals to 2, 9 is less than 4, 2 square. X is equals to 3, 9 is less than 3. Is it true? No, but it can be negative when this is less than or it is less than 0. Here, this condition is not true, but for this we know that the value will be 0. For x is equals to 3, if you place x is equals to 3 over here, your function f of x will be 0, which is again a positive value, acceptable value. If x is equals to 4, then 9 less than x square is false. So you have to consider these conditions. Apart from these, x can also hold a value of negative, say -1, -2, or -3. The squares of these values are also positive. So what are the possible values of x? X can hold any value like 1, 2, 3, -1, -2, -3. Now we've considered only integers. What about the intermediate values? Because the function is real. So what about x holding these intermediate values? It can hold any values, even if it holds -2.5 or even if it holds 0.5, still your function will be a positive real value, will be a real value. So this means that your x belongs to a closed set including -3 and 3, an interval from -3 to 3. These are all the possible values of x that you can place to get a real value of f of x. Now, when you place these values, what values of f of x do you get? When you place x is equals to 0, you get f of x is equals to 3. For x is equals to 3, the maximum positive value, you get f of x is equals to 0. For x is equals to -3, biggest negative value, f of x again is 0. So f of x value, if you place any other value over here, it would be between 0 and 3. 0 over here, 0 over here, 3 over here, and 0 over here. So your value is varying from 0 to 3, right? By observation, you can write your x value belongs to -3 to 3, and ultimately this is your domain. Range will be all the possible values of f of x which are between 0 to 3. Now you have to include both the values 0 and 3. It depends on the value of x. Next, a function f is defined by f of x is equals to 2x minus 5. Write down the values of f of 0, f of 7 and f of minus 3. Now this is simple. Your f of x is given as 2x minus 5. F of 0 means you have to place x is equals to 0 over here. On the right hand side, 2 into 0 minus 5 is equals to minus 5. F of 7 is equals to 2 into 7 minus 5, which is equals to 14 minus 5, which is 9. F of minus 3 is equals to 2 into minus 3 minus 5 is equals to minus 6 minus 5 is equals to minus 11. Next, the function t, which maps temperature in degree Celsius into temperature in degree Fahrenheit, is defined by t of c is equals to 9c upon 5 plus 32. A relation between c and its function t of c is mentioned. You have to find t of 0. So t of 0 is, when you place c is 0, 9 upon 5 into 0 plus 32, which is equals to 32. Next, you have to find t of 28. T of 28 will be equal to 9 into 28 upon 5 plus 32. This will be equal to 252 upon 5 plus 32. This is 252 plus 160 upon 5, which will give you 412 upon 5. Next, t of minus 10. T of minus 10 would be 9 upon 5 into minus 10 plus 30, which is minus 18 plus 32, which is equals to 14. Next, the value of c when t of c is 212. So, t of c is 212. C is equals to question mark. In this equation, place t of c as 212 is equals to 9c upon 5 plus 32. 32 placed on the left hand side. 9c upon 5 will lead you to 180, which implies 9. You can cancel it out here. It's a so 20. Means your C value is equals to 20 into 5, which is equals to 100. The value of C is 100 when T of C is 212. Next, find the range of each of the following functions. You have to find the range. Range means the value of f of x. So in the first question, f of x is equals to 2 minus 3x. And your x belongs to R and x is greater than 0. So x can have any value, positive value of your in your real positive real value. X can hold any positive real value. Now the smallest positive real value of x is 0. So at x is equals to 0, f of x is equals to 2. At x is equals to 1, f of x is equals to minus 1. At x is equals to 2, f of x is equals to 3 into 2, 6. 2 minus 6 is minus 4. As you keep on increasing the value of x, you will get an incremented value of f of x. You will get a decremented value of f of x. But it's given in the question that x should not be, x is greater than 0. So x cannot hold a value of 0. But x can hold any value which is greater than 0. Let's draw the number line for this. I considered x is equals to 0 just to understand what value it can get. But f of x will not be equal to 2 because x is equals to 0. Condition should not exist. So x cannot be 0 but x is equals to 1 will give you f of x as -1. Here at x is equals to 2, your f of x will be equal to -4. That means for all these values which are greater than 0, x can hold all these values. And for that you will get a certain value of f of x. Now the question arises, what is the minimum value of f of x that you can get? Right? So at x is equals to 0, f of x is 2. But at any value which is greater than x, f of x will always be less than 2 because it is approaching -1. So from values between 2 and -1, you will get these values when you place the value between 0 and 1. This is by logic. So your range over here will be equals to any value from -infinity to 0 to 2, but you're not considering 2 because you will never get the value of 2 because x can never be equal to 0. If you place a small value, for example, of x is equals to say 0.01, if you place it over here, you will get the value of f of x is equals to 2 minus 0.03, which is equals to 1.97. So it is a value smaller than 2. It is not equals to 2. Next, your f of x is x squared plus 2 and x is a real number. F of x is equals to x squared plus 2 and it's given that x is a real number. Now there is no restriction on x. No matter what, but there is an x square in f of x. So even if you place a negative value, this will be positive. Even if you place a positive value or 0 value, this is positive. For x is equals to 0, f of x is 2. For x is equals to -1, your f of x is equals to 3. For x is equals to +1, your f of x is equals to 3. So from the number line, if you approach either negative or positive values, your f of x goes on increasing. For 0, your f of x is equals to 2. F of x is equals to 2 over here. For 1 or for -1, your f of x is equals to 3. Beyond this point, if you put it as 2, let's calculate for 2 as well, -2 and x is equals to 2. For x is equals to -2, your f of x is equals to -2 square 4, 4 plus 2 is 6. Here also your f of x will be 2 square 4 is equals to 6. You're getting a 6 value. So the f of x value goes on increasing. But the minimum value of f of x that you can get is 2. So you'll always get a value greater than or equals to 2. That's why we can say that the range of function f over here will be equal to any value greater than 2. So including the value of 2. So 2 to infinity. Third, f of x is equals to x when where x is a real number. F of x is equals to x. X belongs to R. Now f of x is same as x. So if x is real, then f of x will also be real. So the range of f will be equals to capital R, which is a real value. This concludes this exercise. Thank you.